What's going on, guys? So this video is RV related, believe it or not, but in a different way and not one that you might typically think. So today's video is going to be an interesting one, but before we kick it off, I want to give a big shout out to the video sponsor, and that's RV SnapPads. They are a great partner to the channel. They make an incredible product. If you haven't seen them before, they're these really thick rubber pads made out of recycled tires, an inch thick in the center there. You throw them on the landing gear of your RV or your leveling system, or just under a tongue jack, create some isolation. It also widens your footprint a little bit, makes things a little bit more stable, and it also prevents you from having to lower them quite as far. So really cool. We've used them on our RVs for a long time. They work really well, super durable. But yeah, big shout out to the folks at RV SnapPads for sponsoring this video. Definitely check them out. Okay, so we have the main bucket off, and the reason why this bucket is off is because I have my 36-inch bucket coming in, and Don, my friend over at John Deere here in Corpus Christi, is going to bring it over so we can go ahead and put it on. And I've been practicing removing and reinstalling it just so I get used to it, mainly because I don't want to accidentally risk breaking that little grease zerk right there whenever I install it. And there's one on each side, so if you swing too wide and you don't drop those little hooks right into the notch right there, you can have a problem with potentially damaging grease zerks. They're not that difficult to replace, but if I can avoid replacing them, that would be really nice. Well, the focus of today's video, again, is relatively RV related, because, you know, we always talk about frames, we always talk about welds, we always talk about how an RV is built, and I like to compare other products that are manufactured to how RVs are constructed. And in many cases, you know, a product like this, which is designed for heavy construction, which is designed to be used for utility companies and cities and, you know, all sorts of different types of companies, including landscape, lawn care, to be able to do work in the ground, has to be built to a much different standard. But at the end of the day, things are built specifically for the specific use they are going to be used for, if that makes sense. Let me give you an example. You know, we talk about frame thickness and material thickness in frames, and oftentimes whenever you look at the I-beam, or you look at the gussets, or you look at the different outriggers and things like that to manage the frame of an RV, material seems pretty thin and pretty lightweight because the focus really is on being lightweight. Well, when you have something like this, you also want it to be relatively lightweight for what it is, but material thickness is really important, as well as the weld quality, because you want to ensure that something like this can hold up to the conditions that it would normally be subjected to. Let's take a look at some of the differences in material thickness you might see on this versus an RV. All right, starting from the thumb, kind of working our way up the stick over to the boom, let's take a look at some of the things. So first of all, the thumb, this appears to be about 1/2 inch thick, maybe even a little bit thicker than that. But this is a main component in terms of grabbing things and picking them up. So it really has to be just about as strong as the bucket. Now, I have learned some things about how these operate, and the relief valve here should allow you to be able to curl the bucket and press into this without potentially damaging this specific piston. But you do want to be careful, because your piston here for the bucket is significantly larger in diameter than the piston right here. Anyways, moving on. The material thickness pretty much for every component of the thumb is either going to be 1/2 inch thick or 3/8 inch thick. Very thick material. Then we work our way up to the stick, and right here you can see that this is a 3/8 inch thick piece of steel plate that is used to reinforce the attachment for the thumb. Material thickness right here is not quite a 1/4 inch thick, but it is a 1/4 inch thick up here. So in this area and this area right here, it thins out just a little bit. But something I want you to see is the quality of the welds that they use here. Check this out. Look at that weld line. That is amazing. All the way around. And this is probably robotically welded, but check out the qualities of the weld there all the way around. Everywhere that there's a weld, it's an impeccable weld, and there's no slag, there's nothing else stuck to the outside of it, which is really impressive and something that I thought was worth noting. You look at the components down here, again, 1/2 inch thick all the way around. All the components down here are a 1/2 inch thick or greater. Then we take a look at this area right here, which essentially holds the hinging mechanism between the actual boom and the stick, and that is 1 inch thick, or almost 1 inch thick material on each side. And you got some reinforcement plates. Again, look at all the welding. It's really amazing to see the quality of the welds and how robotically welding this stuff really makes a difference. And I don't know if all of this is robotically welded. Shoot, I may have somebody who works in a John Deere factory who does this. So let me know, is this robotic or is this manual? You can tell by where it ends right here that it's likely robotic. And then coming down this way, this all appears to be one large cast piece of steel. I believe this is called the knuckle. Huge hydraulic cylinder right there. You can see what it's attached to. That's probably 3/4 inch thick steel. That's all been boxed off. And again, look at the weld right there at that pivot point. And down here, this is about 1.25 inches thick. This is just a massive piece of steel on each side. You have about a 3/4 inch thick piece of steel right here. Same right here. All of this is just framed incredibly robust. I mean, it's just amazing the type of welding, the type of fabrication that goes into producing something like this. So, and the reason I bring this up is because we talk about weight. The majority of the weight on a unit like this is in this area right here, the bottom section right here, and then all of this structure right here. And this unit weighs 11,000 plus pounds. So we're talking about 11,000 plus pounds in a relatively small footprint that, quite frankly, has a tremendous amount of steel making it up. And when you compare it to something like an RV has to spread all that weight around a much larger footprint, but primarily because you're going to have things inside of an RV that have to take up weight, things inside of an RV that take up space. And all of that really has to be managed so you don't have too much mass. You don't have too much weight in areas where you don't need it, but at the same time in areas where you wouldn't want it. So RVs are designed to be lightweight. They're designed to be relatively lightweight in terms of the size of the RV versus the amenities versus the structure and the frame. And the reason why you want it to be lightweight is because you don't want so much mass built up in the frame and structure that just the frame and structure of that RV, you know, right now, let's say it weighs 13,500 pounds whenever it's empty and 17,500 pounds whenever it's loaded. But if the frame and structure take up 10,000 pounds and then all the materials, everything else you have inside of it before you've put any of your stuff in it, take up another 6,000 to 7,000 pounds, then you have an incredibly heavy unit that has to be really managed in terms of where that weight is placed and how you can load anything else into it. So this is one of the reasons why whenever I talk about weight and I talk about how RVs are designed, you know, quite frankly, they're not designed bad in terms of materials. Typically, if you have a problem with an RV, it was a problem with either a specific component or a specific piece of material on your specific unit or how it was assembled at the factory. And that's largely the responsibility of the manufacturer who's putting it together. And let me explain that a little further. I'm not taking any of the onus away from the component manufacturer, but if the unit is inspected, if the quality control of that unit is really looked over throughout the process, basically if there were more inspection stations throughout the process, then you would likely have a better quality unit only because mistakes would be caught sooner during the manufacturing process as opposed to whenever you get it. And I think that that is definitely one area that the RV industry can improve. Improve the inspections along the assembly line. Basically, before it gets pushed to the next station, somebody needs to come through and inspect everything that was done at that current station. If they integrate that in, it will slow the assembly line down, which means they won't be able to produce as many units, which means dealerships won't be able to get as many units, which means you may not be able to find the unit you're looking for, and you might have to order it. And it might take a much longer period of time, and it may actually cost more, because the slower the process, the less products coming out, the less profit they're making, the less ability they have to turn out new products. But it would probably give you a better overall product, and you would have lower chances of issues with that product once you get it. But again, think of the consequences that it might have. Now, with supply chain issues the way they are, it might actually allow the supply chain components to catch up to the manufacturing side and turn out a product a little bit more complete, right? With the products and the components that they originally intended on putting in it, because they're going to be more readily available because the unit is working its way down the assembly line at a slower pace. So, you know, this is just where I wanted to talk about, again, the differences between how some things are manufactured versus other. RVs are always focused on weight savings, always. Even if you're talking about the most expensive luxury units, they still have a major focus on weight savings because they have to understand what type of vehicle you may have access to tow it. And if they make it too heavy, then they limit your ability to go out and buy a dually or to go out and buy a 450. You might have to go out and buy a class 7 or 8 vehicle to tow it, and that's really going to limit their ability to sell RVs, which is what keeps their doors open and their employees paid. So, you know, you look at something like this, which is purpose-built for construction. You look at something like that, which is purposely built for recreation. You look at something like this, where you do have to have a very heavy-duty trailer to haul it. You look at something like this, where the trailer's built into the actual structure. There's a lot of differences, and it's worth seeing how manufacturers will build something specifically for what it's designed to do, and not necessarily build something or overbuild something only because you want it to be built for a different purpose, if that makes sense. You want, you know, a 1/2-inch thick steel structure on there because you just know it's a stronger structure. But you can do that on something like this where weight isn't as much of an issue. You just have to be really careful on RVs where weight is always an issue. Anyways, guys, I sure hope you've enjoyed this video. Gave me a chance to show you guys the tractor again because I love this thing. I'm still trying to learn it, trying to do a lot with it. And yeah, I'm having fun with it. Guys, if you haven't had a chance, please take a moment, subscribe to my channel, give me a thumbs up, and we'll talk to you again very soon.